All right, all right. Great to see everyone today. My name is Jacob Koh. I'm from Superscript. We're an early-stage fund based out of Singapore and New York, investing into crypto and Web3, and we were seeded by Temasek. But enough about me. We're here today with a really stacked and exciting panel to talk about interoperability. Of course, we've got Bjorn Wagner, the lead contributor to Polkadot and CEO of Parity Technologies, Sunny, the co-founder of Osmosis, one of the largest TVL DEXs built on the Cosmos SDK, Tarun, the CEO of Gauntlet, which does crypto simulation, and Georgios, the co-founder of Axelar. Now, the title of this panel is Bringing Web3 to Billions Through Interoperability. That is a mouthful. Do we really believe that interoperability is the thing that's going to onboard your mom, sister, grandmother, uncle into Web3?
Maybe I'll go first. The answer is no. No, I think what will bring Web3 to billions of people is amazing developers like Sunny here building incredible applications that people find value in. Where interoperability comes in is that we can enable those developers to build seamless user experiences into their applications. I think it's consensus among probably everyone here that the future is going to be one of at least 100 chains that all have substantial economic activity on top of them. And in that future, high-throughput applications like Osmosis here are going to live on their own chain. And the only way to make this future sustainable is by having seamless interoperability across chains so that a user on Avalanche can buy an asset on Osmosis without having to think about switching wallets or all of the UI complexities we see today, right? So while interoperability is not what's going to bring us to billions of users, it is a necessary component, and this is the core infrastructure on top of which all those application developers are going to build.
I could add to that a little bit. A lot of this, what you just said, resonates with me. I think it's somewhat important to remember where this whole topic interoperability came from, right? Like that, I came out around 2016, 17 when Cosmos, Polkadot, right, came forward and said, hey, there's a different way to give developers tools to build useful applications in the world, right? Beyond what was standard back then, which was the Ethereum layer 1 chain, right? EVM. And interoperability, the need of interoperability really came from the realization that Ethereum or the EVM, on one hand, doesn't give developers a tool with which they can build optimized solutions for certain problems they encounter on one, right? So the EVM was just very opinionated in what you can build with it and how you can build on it. There was one. The other ones are some other limitations, right? For example, we all share this one execution environment, right? And that means we are all subject to this fee market. And when CryptoKitties jump through the roof, the demand, right? Like every other application deployed on that execution environment is subject to the negative outcomes of seeing so much demand in another application, in essence, by the fee market spiking, right? So another application's users couldn't engage with it anymore because suddenly transaction cost $100. And so I think a large part of our broader ecosystem, right, came to the conclusion, hey, there's another way of doing that, right? There are more optimized layers than just putting everything on smart contract layer. But that meant you have disconnected execution environments. And when you end up there, right, what is the whole premise of blockchain technology, right? You have this ubiquitous computer where everything can seamlessly, call another function, interoperate, and so forth, right? But as soon as you leave the EVM, as soon as you leave the one-state machine, you end up having that problem that these things need to be talking to each other. Yeah. And that's why the whole topic came up in the first. So it's more, for me, it's more like a technical limitation that we encountered to serve at global scale such a computer.
Got it. Got it. That makes sense. So speaking of disinterconnected systems, and there are different ways in which interoperability works, right? There are different stacks. We've got 3 of them represented here. Maybe we'll start with you, Sunny. Can you maybe frame for us the Cosmos interoperability stack? And we'll go through Axelar and Polkadot as well.
Yeah. The Cosmos interoperability stack, we've built this one protocol that we call IBC, which stands for Inter-Blockchain Communication. And the goal for us was we took a lot of inspiration from the design of like the TCP IP stack in the internet and very much focus on like, okay, be very like specification based, make a set of standards that will have many implementations on it. And so, we built the first implementation on the Cosmos SDK, but there are other implementations of the IBC standard now as well, including on Substrate, which is the development environment for primarily used in the Polkadot ecosystem. There's people building IBC implementations on EVM, on a bunch of different stacks. And the idea here is one of the goals of IBC was to be this like as credibly neutral, non-rent extractive system. You always hear this claim that people are like, oh, imagine like TCP IP had a token and imagine we could have invested in it back then. It's like, what they don't realize is the reason TCP IP won was because it was non-rent extractive. It didn't have a token. It was this credibly neutral thing that everyone was able to standardize around. And that's the goal of IBC, is to build that credibly neutral stack that anyone can implement into their system.
Got it. And the approach of Cosmos, effectively, you have the Cosmos hub, which sits in the middle, and the transactions are meant to sort of go through that, right?
No, actually. No? So that's actually a common misconception, that the way Cosmos IBC works is the Cosmos hub is a little bit of a misnomer of a name. All packets are sent point to point between every chain. So there's no single point of failure in the Cosmos network.
Got it. What about the Axelar network, Georgios?
I think we've drawn a lot of inspiration, by the way, right, from Cosmos and Polkadot, and without them we couldn't be here. So maybe let's go in chronological order and talk about Polkadot first.
Sure. Do you want to frame it for the audience, Bjorn?
Yeah, I would love to. All right. I think there are two parts to interoperability in the Cosmos world, right? One is interoperability within that fairly integrated Polkadot system, and then from Polkadot to other consensus systems, such as individual Cosmos chains, right? Because they're all individually consensus systems, or Ethereum, layer 2 rollups, and so forth. Solana, whatever it is. So let's speak about internally within Polkadot first, right? I think my mental model for Polkadot, that's, I think, the most accurate one. It's a multi-core execution system, right? So you have this validator network, right? That obviously had skin in the game via their stake, and it's basically a sharded system, and each shard in that instance, execution shard, is one core, right? Just like a CPU, like a ubiquitous computer. And like today, this is how it works. Today, each of these execution cores can be assigned or is assigned to a parachain, right? A chain. It's not too dissimilar to what you see in rollups, just that I think it sits somewhere in between optimistic rollups and ZK rollups and combines almost the best of two worlds, because you get via validity proofs, you get kind of like the security and guarantees of ZK proofs, but you still have the flexibility in terms of what you can develop with it, more decentralization of optimistic rollup. So, and now, so that's good, right? That's why we talk about shared security umbrella. All of these chains that rent one of these, lease one of these execution cores is secured and is being made interoperable because Polkadot provides to all of these chains that connect to it what we call, what is in other ecosystems, bridges. Trust minimized, risk minimized bridges.
Got it. So when you say shared security, you're talking about the relay chain of Polkadot, which sits in the middle and it secures all of the parachains. And basically, that's a kind of bridging, right? It's an interoperability stack, essentially.
Exactly. It does two things, right? It provides like, hey, you don't have to build your own validator network, right? You get the full economic security of the greater thing, but also you're provided with a trade routes. But the very crucial step beyond that is that we are somewhat going away from, for example, this one core assigned to one parachain, and going to more of a model that's much more akin to what you're used to from cloud computing, right? Where you say like, well, a core could actually, like if you're a chain, right, you could acquire a core on the spot market, right? For the next block, or go acquire 5 cores, and thereby you get elastic scaling.
Got it. So two interoperability approaches, somewhat different, one point-to-point packets, one a relay chain in the middle. Now, how does Axelar play in all this, Georgios?
Yeah, so with Axelar, we're fortunate to learn from both Polkadot and Cosmos, and we were built at very different times, right? I think when Cosmos and Polkadot were introduced, there was only Ethereum, and they were trying to introduce this new ecosystem of chains that were, I think, very legitimately, like there was a future where everyone would build on either Cosmos or Polkadot or both, right? But there was nothing else. And fast forward a few years, when we started building Axelar in 2020, I think it was the boom of the various layer ones. There was like Avalanche, Solana, a few of those. So we have to think about how do we connect those heterogeneous ecosystems, right? So XCMP, IBC, these are optimal protocols if you can build the stack from the ground up. But with Axelar, we did not have this ability because everyone was building their own stacks. Everything was heterogeneous. And at the time, the way everyone was connected those networks was either through centralized exchanges or through centralized bridges, right? And how do centralized bridges work? You have a custodian, and no one really knows how they work on the back end, right? You trust the team, you have a custodian, you send them the asset, they send you the asset on the other side, right? So there's effectively a guy in the middle that just facilitates this communication, but no one knows what this guy does, right?
And there's problems with that, right? Like we saw on multi-chain, for example.
Multi-chain, I'd say the biggest hacks in the space, the Ronin hack, the Harmony hack, were all due to centralization, right? So the easy answer to that is, how do we decentralize this entity?
Yep.
That, and it's actually the same way that we decentralize blockchains, right? If you remember, in the early days, there were a bunch of proof of authority blockchains. Then I think Cosmos were the first to introduce this notion of a proof of stake blockchain where you could have a permissionless decentralized validator set. So we took inspiration from that, and we created Axelar as a blockchain with the sole purpose of creating, of bootstrapping a decentralized validator set. And today, where we are with Axelar is that every time you pass a message from one chain to any other chain,
right,
it is secured by 75 validators. It's a fully decentralized, permissionless validator set. And if you look at the overlap of the validators of Axelar with any other chain we connect, there's very big overlap, right? So in a sense, attacking the Axelar validator set is similar to attacking like the validator set of any other big chain, right, including Osmosis.
Got it. But when we look at Polkadot and Cosmos, their market caps are in the billions, right? So it's much harder to attack those networks since they're sitting in the middle of the chains. I think Axelar's market cap is close to 135 mil, right? So what happens when the TVL that you guys secure on your bridge gets really large? It's arguably easier to financially attack than Cosmos and Polkadot.
Great question, right? So there's two different attack vectors with those systems. One is the financial attacks, and the other one is corrupting the validators or compromising the secret keys, right? And compromising the secret keys, which has been the main cause of hacks last year, we counter with decentralization, right? So on that side, we have similar level of security as those other protocols. Now on the financial incentive side, the economic security, today, yes, the liquid market cap of Axelar is around like 135, 140. I haven't checked the precise numbers. The fully diluted valuation is around 400 million, right? So it's a little bit higher than that. And all that stake can actually be staked, right? So it's almost everything is staked right now on the network. And that's actually a great topic because we have Sunny as well. We have a collaboration through which we're introducing mesh security, right? So the Axelar network will soon also be secured by the economic security of Osmosis, right? And this is another like $400 million network. And we can introduce security from other Cosmos chains, like maybe even the Cosmos Hub at some point. So we do have a roadmap to add to the economic security. And there's also some other interesting ideas we've been discussing with Sunny. There's an opportunity with EigenLayer to also use Ethereum stake. So you can basically restake it, earn some yield, and secure the network. And hopefully we can do that with Bitcoin as well and get this $500 billion worth of support on the network.
Got it. Awesome. So 3 different interoperability approaches and stacks, Cosmos, Polkadot, Axelar. They all have a blockchain in the middle, essentially helping to secure and validate the network of messages and value and transactions passing through. But you guys are the OGs, right? Polkadot and Cosmos. You've gotten your white paper out in 2016. Your mainnets went live 2020, 21, respectively. But there's a new narrative that's sort of shifting around here, right? We're seeing the dominance of Ethereum in many ways, many roll-ups, OP stack, there's Arbitrum, there's ZK Sync, all of these roll-ups, and they are all settling on Ethereum layer 1. So in many ways, ETH layer 1 has kind of like almost become like a relay chain itself. Tarun, how did we get here?
Yeah, I mean, I think an interesting question, right? At least historically, if you look at 2016, there was certainly this view that, hey, maybe you have to make the protocol itself sort of shard in different ways. Maybe you have to actually have some homogeneity over control of like the interfaces between these different things. And I think Ethereum basically just took a longer route to do this because A, it first had to transition to proof of stake, which happened last year, and that was a quite big deal. But also B, I think Ethereum doesn't have the bootstrapping problem. It has more of the, like, how do we ensure that our existing applications are able to support all of their needs? And what that led to is sort of this very heterogeneous execution environment, heterogeneous execution guarantee system, which in a lot of ways, if you look back at it, it's sort of converging to what Polkadot is. I think once restaking is used to secure Ethereum rollups, you will effectively have created something that looks very similar to the Polkadot model, except there's no auctions.
Right.
But I think the real reason we kind of ended up here is that the Ethereum scaling roadmap took a long time to kind of fully flesh out, but it also got to learn from the mistakes and successes of other networks. And you kind of see that in each of the different rollups, like they each take a different view towards that. But I think one other thing that I would say that is sort of interesting philosophically is Ethereum doesn't really have a first-class principle of owning a notion of interoperability. It doesn't really have some notion of like, hey, Arbitrum, Optimism, and ZK Sync need to conform to some particular standard. Now, the irony is it will move in that direction. So some of the ways of optimizing handling multiple execution environments, whether they're sort of things like dank sharding, will allow single blobs to be used in multiple rollups. And the moment you do that, you're implicitly creating a communication mechanism. So you could argue that Polkadot and Cosmos took the first principles approach to interoperability. Like, it's a core tenet. It's a philosophical stratagem that has to be built in everywhere. Whereas for Ethereum, it was much more the opposite. It was, how do we have this emergent interoperability? And those are philosophically different things that sort of seem to have converged to a very small set of outcomes.
I remember a couple of years ago when, in the bull market, people were talking about Bitcoin and Ethereum, and then they started talking about Cosmos and Polkadot. It's the internet of blockchains, right? And that was such a great narrative. You guys went out there and built it. It's almost like you were too early relative to what we're seeing with the adoption curves. But that is a challenge, right? Because right now we're seeing like 1 billion different startups to make it really easy to build rollups on Ethereum, right? Rollkit, Sovereign Labs, Stacker, Saga, Eclipse, OP Stack, Slush, Dimension, Fastword, Suave, Eclipse, Conduit, Caldera. That's not even half of them, right? So how do you guys compete, Polkadot, Cosmos, right?
I think there's a lot of people building infrastructure, a lot of block space, and I think how we compete is actually just focused on building the products that people want to use. And I think I think Cosmos has done a good job at experimenting on the types of products. The largest stablecoin in the world was built on Cosmos. Doesn't exist anymore, but we had this culture of experimentation, which is good. At the end of the day, today, most of this stuff is mostly used for building trading infrastructure, and perps are the primary volume drivers of trading infrastructure. And if you look at everyone who's building order book-based perps dexes, they're basically all using the Cosmos SDK, right? Whether it's DYDX, Injective, Nibiru, Hyperliquid, not Cosmos SDK, but Tendermint. Our goal is to build the best stack for the apps that actually matter, and that's how we don't need hundreds of thousands of infrastructure providers. We need 10 apps that will bring 100 million users each, and that's how we get to 1 billion.
As an investor, I fully agree with you. There's almost too much infrastructure out there, but it's great that you guys built it. I think you said it there, though, because to build a great app, if I have to deal with all of, bridging my funds from this to that within the app, that's not going to work. So how did you do that with Osmosis? Because Osmosis is kind of built with interoperability in mind, right?
Yeah. So we do a number of different things, right? So Osmosis believes heavily in like vertical integration of like, we think that like the best products are very vertically integrated. You look, this is how Apple makes some of the best products in the world, is by like, the OS knows how, like, it's very deeply optimized for the chip, and that's why we decided to build an app chain. But at the same time, we know when to outsource, right? And so we were like, so you could look at something like Thorchain, right? One of my favorite Cosmos applications. But they decided to build both, like they have their own DEX, and they built their own bridging protocol. But their bridging protocol has gotten hacked twice actually, right? And like they've done a really good job at recovering from that. But we saw that and we're like, that building bridges sounds like a lot of work, and that's not what we want to focus on. And so what we do is we go find partners like Axelar who create like, okay, specialization is also important, and we can like outsource. Okay, we don't want to build the bridging ourselves. We're gonna work with like amazing teams to build the parts so we can specialize and focus on what we're good at.
Yeah. So just cycling back to that, Bjorn, how does, as a lead contributor to Polkadot, how does Polkadot compete, right?
Build a better product. Build an irresistible product. That's what needs to be done, I believe. Particularly if we talk about like these systems that are there to serve at a global scale, right?
Yep.
And so I'll have to walk you through, right? Like there's an aspect of like how many transactions can you do globally across the whole system. That's the charting aspect, right? Get to a point where you have 250 cores, maybe 500 cores, right? That can each pump out like 1,000 transactions per second. That's simplified, right? That's one thing. The other thing, you need extremely good composability between these cores, between the things that run on these cores. And I think I think there's consensus in general in the ecosystem that atomic composability is the best composability you can get, right? Ideally, you want atomic composability.
Right.
That's very difficult, right?
Right.
But I think that's where Polkadot really has an incredible opportunity due to its architecture, because like what we are all tending towards, and what we're all going to get eventually, right, are these trust minimized bridges, which are the trade routes, right? How one can send a message to another. And the language we use in Polkadot, that's XCM. Extremely general. You can send basically any message and tag any information in that message or instruction. But the other key aspect is, how do you know this message will be faithfully executed on the other side? And that's what we call enforced trade agreements.
Right.
And I think that's where Polkadot's shared secure umbrella and architecture really has an incredible edge, where we can build what we call accords, which are enforced trade agreements between these different charts.
Yeah.
And that has some of the elements. And then, again, I think for us all, it's really important to find the sweet spot in terms of trade-off between modularity and integration. So to Sunny's point, right, you can talk about it on the integration application layer, right, like what's the business logic, but you can also talk about it on a lower down the stack, right? If you talk Celestia versus Cosmos versus Polkadot and so forth.
Okay, it's starting to get complicated now, right? And I think this is the problem with interoperability as well. There are so many different ways that you could cut it, different stacks, different approaches. It's so difficult for devs to integrate. Georgios, you're kind of like Switzerland here, right? You work with everyone. You have your own protocol that can work with multiple blockchains. But let's say Ethereum, Cosmos, Polkadot, right? If you had to prioritize ordering the integration of them, how would you do that?
Okay, so first of all, I think it's actually quite easy today.
By the way, I think you should have said fuck, marry, kill.
Sorry? Oh, okay. Ethereum, Polkadot, and Cosmos. Fuck, marry, kill. Which one? What would you do?
Oh my God.
You should moderate this, Tarun, seriously.
I mean, obviously, Mary has to be Ethereum. I'm not going to pick between the other two. I love both. We owe a big debt to Cosmos, as we talked about. Maybe I'll talk a little bit from the perspective of a builder, right, of Cosmos, and why we actually use the Cosmos SDK to decentralize Axelar's validator set, right? So we felt from the very early days that the Cosmos SDK was the most flexible stack, and we needed to do some low-level optimizations in terms of threshold cryptography, so our Axelar validators could collectively sign a message. And at the time, we felt like the Cosmos SDK was the most mature stack, right? And this is the reason why everyone comes to Cosmos. Like, it's the best technology. If you want to build those low latency DeFi applications that Sunny was talking about, right? Like DYDX, Berachain, Chain Network, Osmosis, there's no other option than Cosmos. And just to bring up something negative as well, though, I feel like this is the only reason today, right? I haven't met too many builders that go to Cosmos because they're going to get ecosystem support, right? Like, it's too decentralized, which is great because it's the most mature stack. But if you go and build in Cosmos, you're kind of on your own still, right? And that's something I feel like the ecosystem has to improve on. And I feel like that's something that's also like a really nice thing that we're doing with Axelar, right? Sunny touched a little bit earlier on it. To grow interoperability, we need to get these 5, 10 first applications that are going to build those core cross-chain primitives like cross-chain lending, cross-chain swaps, cross-chain marketplaces. And the same way like those primitives led to the DeFi summer, we're going to see an interoperability summer hopefully next year once those primitives launch and other developers can compose on top, right? And with Axelar, we're super focused on making sure like anyone who's building with us has full access to our go-to-market team. We can help with introductions to virtually everyone in the space. I guess cross-chain really touches everything, and we're in touch with most teams in the space. We can help bring developers in touch, like with exchanges, with other validators, market makers, really everything that took us from the Axelar side like 1 or 2 years when we first joined the Cosmos ecosystem, right? So I feel like, yeah, as a part of the Cosmos ecosystem as well, like we have to be honest and like look at, the things that are not working well. I think, again, decentralization, amazing, most robust stack. But there's more to do, like in how like we take care of builders and like we help them like grow their ecosystem and project.
Well, you're really living up to your name of being the Switzerland of this panel, because that was the most diplomatic answer I've heard all day today. OK, so Tarun, a question for you, right? Do we even really need interoperability? It is so complicated. Some of the developers that we talk to when we speak to them, they say like, we just want simple things. We want atomicity in our transactions. We want our smart contract on our chain to be able to call another smart contract. Now we've got to integrate multiple stacks. We've got to work out where to go. Like, maybe the answer is a monolithic blockchain. Maybe the answer is Solana. Who knows, right? Like, what do you think?
Yeah, so I mean, I think the positive case for Solana is that they are 100% only a believer in atomicity. And like that's their philosophical identity, right? There's like literally nothing else that I would say is the right. I mean, they might get offended. Some people might get offended by me saying it. But it is a very, very distinct choice. I think there's always going to be a sense in which there will be multiple environments. And the things to look back at for the history of that are sort of looking at how Linux evolved and looking at how cloud computing evolved. Cloud computing is sort of an ever-changing kind of compute need type of system. In the beginning of cloud computing, a lot of it was like, well, I just need to run a couple Redis nodes, or I have a web server, and I need to scale it up or down depending on how many users I get. But then if you look at data centers today, the majority of actual energy consumption is actually going towards high-performance computing, which was like not true before. And that's because there are particular applications that happen to find better compute throughput and utilization via different means. So in the same way, you will have high bandwidth, so like many chains type of behaviors, and low latency behaviors that you want to have kind of like a single machine that's very atomic.
Yeah.
I think at the end of the day, though, if you look at Linux, Linux was probably the most successful open source development environment that made a transition from a purely single core atomic architecture to a multi-core architecture that 99% of the developers who are, that you can talk to now who've probably, learned to code in the last 5 to 10 years, probably don't even know that under the covers, the kernel is doing so much to actually schedule transactions across multiple cores, to figure out where memory should be paged, to figure out all of these low-level details that you don't think about. And because of that, you have React. Because of that, you have all these high-level languages that someone can actually like learn over a weekend.
Yep.
And in some sense, that's what interoperability should look like, where the people who are building applications don't even actually know.
Yeah.
But crypto hasn't even gotten to the point where the users don't even know they do that, right? Like, I'll give you a thought experiment. This is like something I try to, there's two kind of thought experiments that I think are worth testing as a way of like how far we are UX-wise. The first is, suppose I have USDC on 3 chains, on Solana, on ETH, and say on Optimism. And I want to do a transaction that says, move all my USDC to ETH. Right now, that is a pain in the ass.
Yep.
You have to sign 3 approves on 3 chains. You have to go make bridge transactions, and then you have to go wait. That whole orchestration effort for the average user is ridiculous.
Yep.
And it's sort of how parallel programming was in the 90s,
Yep.
which is why Linux 2.6 was such a big advancement.
Will there be an interoperability standard that emerges or an approach that emerges that will be able to do what you just said? Because right now, crypto is so tribal, whether it's blockchains, whether it's interoperability stacks. I mean, interoperability is about collaboration. Does that even make sense, right?
Yeah, I mean, in some sense, I suspect it will be somewhat application specific, right? Like the Circle case for USDC, I use that as an example because Circle does have this sort of centralized bridge where they can actually burn on one chain and mint on another if it has native USDC, and they can do that as a single transaction for you.
Yeah.
And I actually think the wallets, especially some of the newer MPC wallets, will effectively be doing orchestration for users to do something like that in a single transaction.
Got it.
But my point is that is hidden from the user. It's not like sitting in their face that they're like clicking MetaMask 20 times.
Yeah. Maybe it's Axelar who will fill that role for people.
Yeah, I mean, I guess one question we get a lot, right, with Axelar is, what's the killer application of cross-chain? And to me, this question makes no sense. Cross-chain is just about user experience, as Tarun just explained. Any application you can build on a single chain, it's exactly the same applications you build cross-chain, but it's much harder, right, because you have this fragmentation. So cross-chain and what we're focusing on with Axelar is building the infrastructure that will make it as easy as possible for developers to build these seamless user experiences. And if we're looking to onboard 1 billion users to the space, it's not going to happen in the future where you have to do like all those multiple approvals, know that you have your asset on Solana. The user shouldn't even know that Solana exists. Right? You should have an application on your phone, use your asset there. Maybe on the back end, the asset is on Solana, the application is on Ethereum, and you're routing it through osmosis for whatever reason, right? The user should know none of that. And towards that future, interoperability is the infrastructure that will lead us there.
Yeah. So, right now, Ethereum, if you believe the stats out there, they've got close to 2,000 developers. I think Polkadot around 600, Cosmos around 500, right? I guess the last couple of questions I had was for yourselves, Bjorn and Sunny. How do we get more people using the Polkadot and Cosmos interoperability stacks, right? Because you're there, but being the godfathers of bridging, would love to see more.
I'm gonna have a stab at it. So within Polkadot, right? Like the parachains, how do we make sure they make use of the power they're given to talk to each other, right? XCM. You got to consider that the delivery XN and the ability to even do that is quite new, right? Even parachains are 1.5 years old. Like parachains were only able to deploy 1.5 years ago, exactly. And
but 1.5 years is like 15 years in crypto land,
correct,
right?
but not the interoperability step. So today we have roughly across Polkadot, like there are 800 applications or projects that are being developed, of which 80 are chains that are connected to Kusama Polkadot, right? And they can now use that power to talk to each other. I give you 3 examples to make it a bit more relatable, right? What this is being used for. So we have one example is Oak Network is a DeFi protocol, works with Mamgada to have essentially auto-compounding, right? Where users one can use the functionality of another one, and this is all integrated. They can relatively easy actually do that, auto-compounding. Another one is Killed, which is a DID network that partner with Deloitte to deliver also verifiable credential around KYC/ML. And Polymag, which is another network in Polkadot that is essentially a compliant fundraising platform, uses these credentials from another champs via XCM in order to be compliant, right? Now, how do we do it? How do we get more folks, right? was there already tons of people, right, like developing and building out, very active developer community. But I think key is education. Make it much easier to understand, make these developer tools so much more ergonomic and smooth working, like orders of magnitude, right? But it's all a time and timing question. Like it took time to build a system that's as powerful as what we've built. And that takes time to build these primitives. And now it's really the time to make it easy and educate the world around and help to understand, also coming from the EVM, the Ethereum development mindset, what you can do with it.
All right, Sunny, what's the exciting development that you think will get more people building on the Cosmos stack?
Yeah, I think like Tarun said on like, Ethereum's ecosystem was able to learn from like the mistakes of Cosmos and Polkadot on the interoperability side. I think actually we have the opportunity to learn from the EVM ecosystem on more of the application development side, where we have a smart contracting system called CosmWasm, but it's the Cosmos SDK, because it has less developers on it, we actually have some more flexibility to be nimble and like develop things differently than the way the EVM works. So I've personally been spending a lot of my time on like a lot of account abstraction stuff, but like baking it more natively into the Cosmos SDK in a way that like is just not really possible in the EVM ecosystem right now. Or I think a lot of the stuff on the privacy side, like my co-founder Dev at our conference 2 months ago, he gave a talk about like, hey, we can modify the CosmWasm compiler that like you can add like 1 or 2 lines of code and you can turn your contract into having like private state. And like I think taking how the Cosmos SDK and CosmWasm as a development stack is going to win is to provide features and things that people can only do on the Cosmos SDK stack. And this is like, for example, one of the reasons why DYDX chose to build on the Cosmos SDK was they wanted to have more fine-grained control over how transactions get ordered in their blocks, right? They wanted to figure out, if you're building a perp sticks, they want to figure out how do you make cancellations free, right? They need fine-grained control over gas markets and transaction ordering and things like this. So how Cosmos SDK is going to win is building functions that people can only do on the Cosmos SDK and nowhere else.
Got it. So I mean, just to recap, right? Part of it is education. Part of it is developers building good apps that people want to use. Part of it is bridging infrastructure, SDKs, becoming so simple and easy to use, they kind of fade into the background. That's part of our investment thesis as well when we invest in Web3. Thank you so much, guys. This has been an amazing panel. Ladies and gentlemen, these guys are the gods of bridging. They're in the arena bridging stuff. A big hand for them.